So today we are looking at section 8.5. So divide radical expressions. Divide radical expressions. So last week we were discussing on we discussed something on radical expression where we said if the nth root of A and the nth root of B are real numbers where B is not equals to 0, where B is not equals to 0 for any integer n greater or equals to 0, for any integer n is greater or equals to 0, then the nth roots of A all over B equals to the nth root of A all over the nth root of B. Or the nth root of A all over the nth root of B is similar to the nth root of A all over B. Now, for example, if we have an example like the example which I gave you in the notes, example number 1. The cube root of 243 u raised to 10 all over the cube root of 3u squared. The cube root of 243 u raised to 10 all over the cube root of 3u squared. So simplify that. So this is similar to the cube root of 243 u raised to 10 all over 3u squared. So it is similar to that. So here you can be able to cancel the one which you can cancel, and then for this, if you divide by 3, will this one divide by 3? So it will, right? So this by 1, by 3 is 81. And then this, you take it up here, minus what? Minus u. So finally, what you get is the cube root of 81 u raised to what? So this is 2. U raised to 8. 1 u raised to 8. Now, you can still simplify this. Again, you can still simplify that. So you can get a factors of 81 So H1, so you can try get factors of H1. So if you divide by 3, what do you get? Is it 27? Right? And then 3, you get 9. And then 3, and then 3. So how many 3's are those? There are 4, right? So for A1, you have now the cube roots of 3 raised to 4. And then multiply by what? U raised to 8. U raised to 8. Again, you can still simplify this. And this is also similar to the cube root of what? The cube root of 3 raised to 3, and then multiply by 3 raised to 1, right? And then u raised to 6, and then multiply by u raised to what? U raised to 2. Okay? So this 3 is, so the bases are the same. So you can add the power, right? You get 4. So here, the bases are the same. The power, you get what? 8. Now you can now simplify from there. So you multiply by, we know that the cube root is the same as 1 all over what? All over 3. So when you multiply everywhere by 1 all over 3, then what do you get? So this is equals to, so this 3 will be raised to 1, and then this 3 will be raised to 1 over 3, right? The next 3. And then this one will divide by, when you divide by 3, then you get what? U raised to what? U raised to 2, right? And then the cube root of 3, and then U squared. The cube root of 3 U squared. So that's how you can use, or you can simplify that.
I have a question.
Mhm.
If 8 can be cubed perfectly by 2, why can't we just cancel the U8 and just pull over as U squared on the outside?
This is cube.
Mhm.
So, so you're saying if we do what from here?
Yes, you can cube 8 perfectly by 2, so you just pull it out as U squared without having to have the U in the equation still to be cubed.
So you're saying we pull out the u to be
U squared.
u squared all over 3?
Yeah. So it'd be like 3U squared and then cube 3.
So it's not cube, it's 1 over 3. Because it's the cube root.
Yeah, but I mean,
So
2 times 2 times 2 is U, so U cubed evenly would just pull out as U squared.
so I'm trying to get what you mean. Would you come and
Yeah.
Yeah.
Okay. So like, if it's 2, if you simplify all the way down so that it's the cubed root of 3 cubed times 3 times u to the 8th,
Mhm.
then u to the 8th keeps perfectly as u squared, and then these 3's cancel, so it's 3u squared to the cube root of 3. Would it work like that?
Because you have 8 here, so it's not dividing.
2 times 2 times 2 is technically like u squared cubed, and then the cubes cancel, so you can pull out the u squared wholly.
Oh, I get what you mean. Oh, let me explain to you. Okay. So let's do it slowly. Yeah? So this is cube here, and then we have the 3 raised to 4, and then u raised to 8, right? So here we are trying to look for, because what you mean is you're saying because u raised to 2 raised to 3, right?
Mm-hmm.
And we know that this one is raised to 1 over 3.
Mm-hmm.
So it is not the same as, because all this is the power. The 2 raised to 3 is the power of that. It's not like the power of this. It's not like u raised to 2 all over 2 raised to 3, and then again the cube root of this. It's not like that. You get what I mean? So it's not like this. It's not that you're getting the cube root of 2 raised to 3. It's you're getting the cube root of the u raised to 8.
Oh, I see.
Yeah. So if it was the cube root of 2 raised to 3, then it could be like this. So you cancel the 3 here, then it becomes u raised to 2. But now it's the whole of this one, which is u raised to 8, the cube root of that. So the cube root of this is the same as equals to the cube root of u raised to 6 times u raised to 2. Okay? So you multiply everywhere by 1 over 3. So u raised to 6 times 1 over 3, u raised to 2 times 1 over 3. So that and that will be 2. This will remain like that. So it will be u square, and then the cube root of u square. Okay? Yeah, so it is like that. So we have another example there, which I know you can solve that, but maybe you can solve it. The cube root of 162 y raised to 8 all over the cube root of 3y cubed. The cube root of, so all of this like that. So this is similar to the cube root of 162 y raised to 8 all over 3 y raised to 3. So it's similar to the one which we did. So now you simplify. So it is equals to the cube root of, if you divide by 160, by 3, 1, by 3, 1, 51. 154, right? So 54, and then y raised to 8 minus 3. So what do you get? So the cube root of 54 y raised to what? Y raised to 5. 54 y raised to 5. Now using the same way, then we can get the factors of 54 here. So if you get 54, if you divide by 2, you get what? 27. Then if you divide by 3, you get 9 by 3, and then 3. So here you have now the cube root of 2, same as 3 raised to 3, same as y. So we can split this y raised to 5 so that we can get the one which can be divided by 3. So y raised to what? Y raised to 3, same as y raised to 2. Y raised to 3, same as y raised to 2. Then now you simplify from there. So when you multiply everywhere there by 1 all over 3, the powers by 1 all over 3, then this will now be equals to, this will be 3 outside, this one will be y outside, and then the remaining ones, the cube root of what? 2, and then y squared. Cube root of 2 y squared. Any question? All right, so let's come to the next section, which is rationalize a one-term denominator. Rationalize a one-term denominator. Rationalize a one-term denominator. So you can write this. Rationalizing the denominator is the process of converting a fraction with a radicand in the denominator to an equivalent fraction whose denominator is an integer. Rationalizing the denominator is the process of converting a fraction with a radicand in the denominator to an equivalent fraction whose denominator is an integer. For example, 4 all over the square root of 3. 4 all over the square root of 3. So this is the numerator. This one is the denominator. So we want to rationalize the denominator. So how should we rationalize this denominator? So what you do is you multiply by what? The same value here, which is the cube root of 3 all over the cube root of 3. So you multiply by cube root of 3 all over the cube root of 3. Because this is similar to canceling this, you get what? 1, right? This, when you cancel this one and this one, you get 1. Now, when you multiply by this, then it will be equals to what? 4, the cube root of 3, all over what? This one and this one will be what? So this is cube root of 3 by cube root of 3. So cube root of 3 by cube root of 3 is equals to what? So this is similar to 4 root 3 all over the cube root of, the square root of 3 square. The square root of 3 square. Now the square root of 3 square is what? Is 3. So finally, our answer will be what? For the square root of 3 all over what? All over 3. So that's how we rationalize that. So we multiply, because this is only one denominator. So we may just multiply by this radicand here. So here, so we multiply in the numerator and at the same time in the denominator. So we have an example number 3 there. Example. You done with this? Example. Simplify 3 all over the cube root of 15 cube. 3 all over the cube root of 15 cube. Now, how should we rationalize that? How should we rationalize that? How should we simplify that? So we want to make this denominator to be, we want to make this denominator to just be the integer without any radical there. Now, how should we remove this cube root here? How should we remove it? How should we remove that? So what we do is, this is similar to, so this one is similar to 3 all over the cube root of 15 cube times 3 cube root of 15 cube square all over 3 all over 15 cube square. Okay. So because we can still cancel this and this to become what? 1. To become 1. Now, when we simplify this, what do you get? So when you simplify, then this is similar to 3, the cube root of 15q square all over. Now, this 15q is the same as what? The same as 15q raised to what? 1 all over 3. Okay. And then times what? This is 15q raised to 2 over what? 2 all over 3. Okay? So this is 2 all over 3 because this one is the square here. All right? Now, when we simplify, then what do you get? So that means the bases here are what? They're the same, right? So we add the what? The power. So when we add the power, what do you get? So 1 over 3 plus 2 over 3. You get what? You get 1. So finally, our answer will be what? 3, the cube root of 15q square, all of what? 15q. All of 15q. So again, you can cancel this and that, you get 5. So you get the cube, 3 cube root of 15q square, all of 5q. Are we together there? Right. A similar example is in example number 4 there. So you multiply by the square. So we want to change the denominator. We want to remove the radicand there. So we want to remove either the cube or the square root at the denominator. So by simplifying it, we make sure that we don't have the radicand at the denominator. We just have the integer. Okay, now rationalizing 2 terms. Now let's come to the next section. Rationalizing 2 terms. Rationalizing 2 terms in the denominator. So we can recall this, a minus b, a plus b is similar to what? A squared plus what? Sorry, minus b squared. Now, if this one is in the denominator, then this will be like that. Now, again, if we are given 2 minus the root of 5 multiplied by 2 plus the root of 5, yeah? Now, using this first one, that means this one will be equals to what? 2 square minus what? The root of 5 square, right? So 2 square minus the root of 5 square, which is similar to 4 minus 5, which is equals to minus 1. Is equals to minus 1. Now, if we have this example So if you're told to simplify the root of 7 all over the root of q plus the root of 13. Simplify that one by rationalize the denominator. Rationalize the denominator. Now, how should we rationalize the denominator? So what we do is we multiply by the what? We always call this one the what? The conjugate, right? So we change the sign here. We multiply by this one in the denominator, and in the numerator, we multiply by the conjugate of this one in the denominator and the numerator. So that means it will be equals to the square root of 7 times the square root of q minus what? All over that plus times what? So we multiply by the conjugate in the denominator and the what? And the numerator. And then now you simplify. So in the denominator, so this is a difference of what? 2 squares. Let's give you a difference of 2 squares. So finally, our answer will be all over what? The difference of 2 squares will be what? The square root of that square minus the square root of 13 square. Okay? And our final answer will be what? So it will be the square root of 7 q minus 13 all over q minus what? Minus 13. So that's how we simplify that. So you multiply by the conjugate in the denominator and the numerator. Okay, another example. Second last example in our notes. Simplify 9 plus the root of 17 all over 9 minus the root of 17 by rationalizing the denominator. By rationalizing the denominator. So you should know which one is the denominator and which one is the what? Numerator. So this is the denominator, this one is the numerator. So here, you multiply by what? The conjugate of the what? Denominator. So you multiply by 9 plus the root of 17 all over 9 plus the root of 17. Equals to 9 plus the root of 17 times what? 9 plus the root of 17 all over 9 1 square, right? Minus the root of 17 square. Because the denominator is a difference of 2 squares. Difference of 2 squares. So as you can see, this is similar to what? This one is similar to. So finally, our answer will be what? 9 plus the root of 17 square, all over what? 81 minus what? Minus 17. 81 minus 17. So what do you get? So finally, you get 9 plus the root of 17 square, all over what? Is it 64? All over 64. So that's how you simplify. Okay, we're done with this. All right, let's do the last one, the last example. I think it's also similar to what you've done. Simplify the square root of 38 minus the square root of d all over the square root of 38 plus the square root of d. So again, multiply by the conjugate of the denominator. So you multiply by what? The root of 38 minus the root of d all over the root of 38 minus the root of d. Now, looking at the numerators there, they are similar. So it will be the root of 38 minus the root of d square all over 1. The root, the down one, the denominator is what? Difference of 2 squares. The root of 38 square minus the root of d square. So our final answer will be the root of 38 minus the root of d square all over 38 minus d. I know some of you will do a funny thing here. I know some of you will slot in. We simplify this by saying, because this one is a square, then we square this, and then we square this. Get 38 minus 38. And then our final answer will be 1. That one is very wrong. So this is, there is a minus here, and you need to expand like this. So when you expand that one, then of course it will be like 38 minus 2 root of 38 root of d plus 1 plus d. If you simplify, if you expand this one. But you can leave it like this. So you can leave it like by putting the square there. But if you want to simplify, then when you square this, then of course what you get is what? So when you square this one, then when you square this, then it will be this one square, which is 38, minus twice this and this, to the root of 38, the root of d, plus the square of plus d, all over 38 minus d, if you want to simplify. So if you want to simplify, it can be like this. Or you can just leave it like that. Okay? All right. Any question? Avalos, Benjamin, Gregory, Ashley, Victoria, Rachel, Bailey, Laura, Adam, Kavehi, Andrew, Destiny, Call, Abby, Aliyah, Aldo, Jillian, Remington, Midon, Rayleigh, Eric, Kayla, Relay, Rock, Ethan, Samuel, William, Otman. You don't have any question, then you are free to go. So make sure you finish your homework, sir. Finish your homework.
So when you do the Zoom, is there like a password for it?
Let
Do
me
like the live Zoom?
see what it is.